Hello and welcome back, critical thinkers. Today's TEK is G3B. Determine the image or pre-image of a given two-dimensional figure under a composition of rigid transformations, a composition of non-rigid transformations, and a composition of both, including dilations where the center can be any point in the coordinate plane. This specific video covers translating or sliding a figure on the coordinate plane. Our learning objective is to be able to translate a figure in the coordinate plane. Now, you will know you have mastered this objective when you can take a formula and you can move a figure from a pre-image to its image. Or when you can look at a drawing, when you can look at the coordinate plane and you can see the image and the pre-image, and you can come up with the formula that maps the pre-image onto the image. Now remember, every skill you learn in this video makes you a stronger problem solver. Now I know you can do this, so let's turn your practice into your superpower. Let's look at the definition for a translation. A translation is known as a transformation that moves all points of the original figure. And we know that the original figure is the pre-image. It's what we start with. And we're moving all of these points in the same distance and in the same direction. So we know that this is a congruence transformation because the size and the shape stay the same. Another way of looking at a translation is this, that we just shift the figure in the coordinate plane. It's like it has wheels and we just move it around on the coordinate plane. If we look down here, we're going to see our pre-image ABC, triangle ABC. And what we're doing is we're going to take this pre-image and we're going to move it in this direction and this distance. And so what happens is the triangle now turns into triangle MNO, but it is a transformation of triangle ABC. And so the way that I notate this is that I write it triangle ABC is mapped onto triangle MNO. Remember, this arrow means that a transformation has occurred. Again, we took our pre-image right here, triangle ABC. We slid it down in this direction, and every point on this triangle moved the exact same distance. So A moved to M, C moved to O, and B moved to N. So if I looked and measured each one of these glowing red lines, what would happen is all of them would have the exact same measurement because they've all been moved the exact same distance. Every point on these two triangles would be the exact same distance apart. Since the two triangles are a congruence transformation and they have been mapped one to the other, I can say that these two triangles are congruent. So I know that triangle ABC is going to be congruent to triangle MNO. These three little dots are a simplified way of just writing therefore. So whenever you see three dots as a triangle, it basically means therefore. So if I would read this, it would read triangle ABC is mapped to triangle MNO. Therefore, triangle ABC has to be congruent to triangle MNO. When we know that two triangles or two polygons are congruent, we can say that all the angles are congruent and all the sides are congruent. All angles congruent, all sides congruent. So I can basically look at this and match up the angles. I can say angle A matches with angle M. Angle B matches with angle N. Angle C matches with angle O. So those angles have to be congruent. Again, looking at the figure up here, A goes with M, B goes with N, and C goes with O. So all of those angles measure the exact same. Those angles are congruent. And you know that by the way that the correspondence is set up. In first position here, we have A and M. In second position, we have B and N. In third position, we have C and we have O. So I'm going to write down the angle congruence. I'm going to say angle A and angle M are congruent. Angle B and angle N are congruent. And angle C and angle O are congruent. Now, I just used one letter to name the angle, but we know that we can use more than one letter. And sometimes we have to because the one letter is not going to be specific enough. And so I could write it as angle BAC is congruent to angle NMO. And notice that the vertex is in the middle, right here, the A and the M. Here, B and N are vertexes right here. Notice that B and N are in the middle. Here, C and O, and notice C is here, O is here in the middle. And so we can name it by one letter when we just have two triangles like you see up above, or we can name them using three letters that gives us much more specificity. So when we know that we have a congruence transformation, we know that the figures are congruent. So once I know that, I can say that the angles are the same and the sides are the same. So I put my sides over here on the right. All sides of the two triangles are congruent. I know that AB here matches up with MN on this side. BC here matches up with NO here. CA matches up with OM. So that sense of correspondence where you see this first letter here, these two letters have to go together. So when you're looking down here, notice A is in first position, so M is in first position. A is second here, M is second here. So the A and the M match. The B and the N match. The C and the O match. Another way of saying this is that the corresponding angles, the matching angles, are congruent. The corresponding sides here, or the matching sides, are congruent. We know when we have congruence transformations happening that we have congruent corresponding angles and congruent corresponding sides. Let's talk about a translation formula. Another name for translation formula is a function notation. And it tells you how to adjust the X and the Y coordinates in order to move from the pre-image to the image. So these are the marching orders for each one of those points in our pre-image, telling it where you go up and where you go over. How many do you go up or down? How many do you go back and forth? And the formula looks like this. You have your coordinate, X and Y, and it's telling you what we're going to have to do to the X and Y. So this is our pre-image here, and then we're mapping it onto our image, which is over here. Now we're going to take this x and we're going to add something to it. So this becomes x plus a. We're going to take our y here and we're going to add something to it. And that's how we get our y plus b. So this is known as a translation formula, but it's also known as function notation. An example looks like this. So here we start out with our pre-image, xy. What are we going to do to the x's and what are we going to do to the y's? Well, what we're going to do is I'm going to add 3 to all my x's and I'm going to subtract 5 from all my y's. So what this means in basic words are that every point of the pre-image moves 3 units to the right. That's the x plus 3. 3 units to the right. And then it moves 5 units down because this is minus 5. Plus 3 moves, we go to the right. Minus 5 means we go down. If it was plus 5, we would go up. And if it was minus 3, we would go to the left. Now, function notation right here, the xy, mapping it onto x plus a, y plus b, where a and b are real numbers, represents a mapping from one set of coordinates to another formal definition. But what I basically need for you to know is that if you want to translate something, if you want to slide something on the coordinate plane, what you're going to do is you're going to add something to the x's. It might be a positive or a negative number, and you're going to add something to the y's. It could be a positive or a negative number. And that's going to be enough. If you do it to every single point in the figure, that's going to shift that figure to a new location. Let's work together on a practice problem. The instructions read, translate the triangle using the translation formula of xy is mapped onto x plus 5, y plus 10. So looking at this formula, I immediately know that this plus 5 means that this figure is going to move to the right. I also know that this plus 10 for the y's means that it's going to go up 10. So I am making this figure move over 5 and up 10. Just by looking at the formula, I can tell that. So this is my pre-image right here, okay? And so what I'm going to do is I'm going to take this pre-image and I'm going to move every single point to the right 5 and up 10 to get to my new image position. So let's look at, we're just going to do the vertices because if I do the vertices, then I can just connect them to get where all the other points should be. So what's going to happen is this A is going to go 5 points to the right. 1, 2, 3, 4, and 5. Now, I'm going up because I have to go up 10 for my y's. So what's going to happen is I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And this becomes my new A prime. So my A has moved from this location up to this location right here. Let's look at C. So the formula tells me I move 5 over. So I'm going to move 1, 2, 3, 4, and 5. And now it also tells me that I'm going to go up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So notice that the C's have moved from here up to here. Let's look at our B's. So the B's, the formula stays the same. So I'm going to move this B over 1, 2, 3, 4, 5. And now I need to go up 10 because that's the formula. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So my B's move from this location up to my B prime, which is here. Now notice, all of these have to be the same distance, over 5, up 10. When I do that to each of the points, when I follow my formula right here, I end up getting my new image at these locations, A prime, B prime, and C prime. Now, I just want to say that these two triangles, ABC and A prime, B prime, and C prime, these two triangles are congruent. They have the exact same side length and the exact same angle measurements. So these two triangles are congruent. Solving this mathematically involves creating a table. It's the simplest way to do it. I take my vertices, my A, my B, and my C, and I write down the coordinates of each, my X and my Y coordinates, and then I follow the formula. So I wrote a column for each one of the formulas. For the X's, it's X plus 5. For the Y's, it's Y plus 10. That means I move my figure over right 5 units, and I move my figure up 10 units. So I'm going to take my X's and I'm going to add 5 to each one of my X coordinates. Negative 14 plus 5, negative 7 plus 5, negative 5 plus 5. And that's this column here. This tells me my new coordinate for the X's, for the image. So this right here is determining the image coordinates. For the Y's, I'm going to take my Y values here, and the formula tells me I have to add 10. So I'm going to take a negative 8 and add 10, a negative 4 and add 10, and a negative 14 and add 10. That's this column right here. When I simplify it, I get my 2, 6, and negative 4. I then put these two numbers together, the X and the Y's, and I get my image coordinates for A. My X and my Y, I get it for B. My X and my Y, I get it for C. Now, I can just do it mathematically and then plot them, and it would look the exact same. Notice that we did it graphically by counting over initially and then going up on each one of these. But we could have also done it just mathematically without even drawing a graph. And you can see that we would end up in the same position with the same answers. Now, let's see how you can apply what we have just learned. The instructions read, translate the triangle using the translation formula of xy being mapped onto x plus 5, y plus 10. We know that triangle XYZ has the following coordinates. X is at 2, negative 6, Y is at 5, 10, and Z is at 12, negative 1. Remember to show your work and be sure to box your final answers in. Your written work should clearly show your thinking so that I can follow your logic step by step. If you have any issues or you have any questions, please ask for help. You may check your answers on the next slide. Now please pause the video and complete your work. When you are finished, press play to continue. Here is the answer to the problem. Please pause the video and check your answers. And when you're finished, press play to continue. Now, please notice that I did my table first, and then I actually graphed it. So you'll notice that we have the pre-image coordinates here, the formula that was given to us is here, and then our last column has the image coordinates in here. When I graphed it, I should just to see up here, notice that I graphed the pre-image in pink and the image is in green. The corresponding vertices are X and X prime, Y and Y prime, Z and Z prime right here. In order to move from one location to the other, let's just look at the X. What's going to happen is I moved over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I moved back 12 and down 1, 2, 3, 4. Back 12, down 4. Back 12, down 4. And so when I'm looking at that formula, it should express that, and it does. X minus 12, which means I'm moving 12 to the left, and then this minus 4 right here for the Y's means that I am moving down. So my graph and my table are saying the exact same thing. This is it for today's video. If something doesn't make sense, that is your cue to ask questions. In fact, it's your responsibility to ask questions. Now, you can come to me, you can talk with your classmates, your shoulder partner, or even try AI for a step-by-step explanation. Remember that we're a team here, and we're all here to help one another succeed. You learn best by breaking complex concepts down into smaller, more manageable skills. And that's exactly what we did here today. You are turning your practice into your superpower. Please know that I believe in you and that I know that you can do this. You are working your way to success one skill at a time. Now have a great day, and thanks for working with me.